Okay, so today we're talking about money. It's kind of a fun topic. Let's start with the basic idea of compound interest. Before we even use the formula, let's just start talking, if you put money in the bank. So let's say you put $100 in the bank, right? So $100, and after no time, that's how much you have in the bank. And they give you 2% interest a year. So after 1 year, you're going to have two more dollars. You're going to have $102, right? Because you got 2% interest. The magic of compound interest is what happens after 1 year. So after 1 year, so 102. Whoops, let's type this in 102 times zero point zero 0.02. This may not seem like much, but the second year, they give you not just $2, they give you $2.04 because you get interest on top of the interest. It's called compound interest. So we have $104.04 after 2 years. And then, so now we have 104.04, and we're going to get 2% of that. I think we get a little bit more the next year. So I'm going to round that off to the nearest cent. So I'm going to say 2.08. 2.08, just a little bit of rounding there. So 106.12 after 3 years. So we had the money in the bank for 3 years. We're rocking and rolling here. I mean, now we've got $106 instead of $100. Okay, 106.12 times 0.02 to the nearest cent. That's $2.12. We are just killing it here. Okay, so 108.24 after 4 years. Let's get one more year because it said 5 years, I think. So 108.24 times 0.02. That last year we get $2.16 approximately, rounded off. So we get 110.40. So that's how much money we have after 5 years. Let's use the formula. So the formula is right here. This is kind of a basic formula. A couple of things you need to know. This is like the amount. It's written in amount. This is written in function notation. It's the amount after 5 years. So if I were plugging in, this would be the amount after 5 years, which is the amount of time. That's what that means. Not A times 5, it's the amount after 5 years. P stands for the principal. That's how much you invest. So in this case, $100. We put $100 in the bank, so that's 100 times 1 plus the rate. Be careful with the rate. The rate is always written as a decimal. The rate as a decimal. Do not write it as a, if it's 2, don't put 2. You want it as a decimal. So this would be 0.02 as a decimal. N is the number. Let's see. N is the number of times compounded a year. Number of times compounded. So if it's once a year, sometimes compound interest, like this example, is 1% a year. So it's compounded once a year, maybe the end of the year. Sometimes you have monthly compounding. Sometimes you have daily compounding. We'll even talk about continuous compounding. It could be quarterly. That would be 4 times a year, but this is definitely once a year. So we're going to put in 1 there. To the n, which is 1, times t, which is time in years. So it was 5 years, I believe, for this one. So 1 times 5 is the exponent. Those are both exponents. So 1 times 5 there. So if you get out your calculator and you go, okay, let's type this in. So 100 times 1 plus the rate of 0.02 over 1 to the power of 1 times 5. We got 110.41 if you round it off to the nearest cent. The reason there's a rounding difference is here with the formula, you basically round at the end. Doing it by hand, the old-fashioned way, that would take a long time, it's a lot of years. You're going to get, you round after each year, so it's slightly different, the rounding at the end. I'm not worried about a penny difference here. So once you get the idea of compound interest, kind of how that works. And those are the official, if you want to write it down, those are the official names. They're on your sheet. In fact, if you want to download this sheet from, I kind of have your notes out there for you. So if you're in my class, you might want to download this piece of paper. So compounding method, if it's semi-annual, that'd be twice a year. If it's quarterly, that would be 4 times a year. So the only thing that would change in this formula, like if I want to do semi-annually compounding here, so the formula, the thing that would change would be the 1. So semi-annually, that would change to 2. That means I'm getting, it doesn't mean I'm getting twice the amount of interest, actually. It means I'm getting half my interest after 6 months, and then I get the other half after the next 6 months. So it's going to be a little bit more. When you compound more often, you're going to get a little bit more. So this answer was 110.46. So we got 6 more cents if I compound twice a year. Let's see how much we get if I compound four quarterly or 4 times a year. So copy and paste, and that's going to be 4 times a year, and that's going to be 4. So 110.49. So all things being equal, if you had 2 different banks and one was compounding more often and they have the same interest rate, you definitely would want to go with the one that compounds more often. You're going to have a little bit more money, because in that case, you're getting 1/4 of your money after 3 months, getting another 1/4. And so you're earning interest on top of interest on top of interest, which is the beauty of compound growth. Okay, so this is usually a little tougher for students for some reason using the calculator app. So there is a calculator app, but if you do this, 84 has this as well. It's kind of built in. So if you go to a calculator page or Scratchpad, if you menus, you see something about finance, and there it is. I think it's choice number 8 for me. And you want to go to the finance solver, the first choice. And you get this kind of table here. It's got all these kind of stuff here. It's explained or defined here. I never start. If I start with interest. We'll come back to N in a minute. N is probably the most complicated piece there. I hit tab to go to the next cell. So when you're entering the same problem in the calculator, you want to enter this as a percent, not as a decimal. So you do want to put, see how it says percent, interest in percent? So I'm going to put 2 there because it is 2%. Future value is your goal, or the present value is present value. Present PV is your starting point. So how much money did you put in the bank? $100. Now you have to use what's called the cash flow convention, and what that means is I'm not going to put a positive 100. When I invest money, I give it away. I give it to the bank temporarily, and then they give it back to me at the end when I cash out. And so in accounting terms, that's a cash flow convention. That's going to be negative. So I'm going to put negative 100 instead of positive 100. The thing you run into problem, if you make future value and present value positive, you're not going to get an answer. It's going to give you an error. So that's important. In this case, there's no payment. Sometimes you're investing a certain amount after every year or every month. That's not the case here. So there's no payment. It's just a starting point. And think of present value as an initial starting point. Think of payment as like a recurring event, like you're paying your mortgage every month or your car note. You're doing something every month or every year. In this case, it's just a one-time deal. Put $100 in and let it grow. Future value is what we're going to have at the end. We'll come back. We'll solve for that in a minute, but we're not ready for that. PPY is basically the payments per year. This is how often it's compounded. So for our purposes, in this case, it's just once a year. And by the way, whatever PPY is, CPY is as well. So it'll default that way. So we're just going to leave it at 1 right now. And then we'll come back and solve for N. So N is probably the sneakiest one. It's number of payments. So I think of this as number of payments, which is basically like your CPY, like your number of years times how often you compounded. So your CPY, basically, whatever you wrote for CPY. In our case, our CPY was, our number of years is 5, and our CPY was 1 for this problem. So I'm even going to type it in like that. I'm going to type it in as this is going to be 5 times, it's compounded once a year, so 5 times 1. When I do that, it'll calculate 5. It'll multiply numbers for me. And go back down to what we're solving for, which is future value. It says at the bottom of the screen there, if you read it, press enter to calculate. So I'm going to calculate the future value, which is 110.408, which is the exact number our calculator got when we did that using the formula. So the calculator is basically using the formula to solve this for us. And this is really going to be helpful. You have to learn the calculator method as well, because I might give you a problem with a payment, and we won't have a formula for a payment. There might be a formula, but we're not going to use one. It's not part of this class. So keep that in mind. You do need to learn this thing. So let's just change it slightly. There's just some other information about that. But let's remember we changed the compounding. Let's make it 4 times a year. So if compounded 4 times a year, I'm going to tab down there, change that. The CPY automatically changes, and that would change my N value, right? Because N value is going to be 5 times how often it's compounded. In this case, 4, 5 times 4. If I tab down to future value and press enter, it'll solve for that future value. It's going to be $110.48, which is what we got again with the formula. So this is, and by the way, that's a positive value, which means it's an inflow. Like when I take the money out of the bank, that's positive. I get the money. I give it to them temporarily so they can loan it out, make some money, and then they give it back to me at the end. By the way, you may just kind of be thinking like, why are we studying about money when we were talking about exponential growth? So if you think about the graph for exponential growth, the graph looks kind of like this, right? It grows really fast. And if you think of, in fact, even when you look at this formula, where's that formula? This p-value is like your y-intercept on the graph. So like that's kind of your starting point. So it's, it's kind of like your p-value here. In this case, $100 for the example we just did. And it starts growing, and it grows at a faster and faster and faster rate because we're kind of, it's not growing quite that fast yet, but it's going to grow. It just takes a certain number of years in order to double, and then it doubles and doubles and doubles and doubles and doubles. And so your money, if you give it a long time, is going to actually grow gigantic. It's going to be, everybody can be a millionaire. I teach you how to do that today. In fact, this example is about that. So your money grows exponentially because it's called compound interest. You're getting interest on top of interest. So let's say you make a New Year's resolution to stop going to Starbucks. I think Starbucks could be a $5 drink there pretty easily. Instead, you decide to invest the money. So at $5, you're going to put it in a growth stock mutual fund. So if the mutual fund gets 10% a year, let's even downgrade that to 9%. Although like for the last 100 years, it's averaged about 10.5%. Now, take advantage, understand, sometimes it goes down. There's some years it goes down. A lot of years it goes up. But on average, you can see that 10% right there. On average, it's around 10% growth. But we're going to use 9% for our calculations. So let's see how much money we would have if we invested $5 a day. So let's kind of think about that. So let's say the typical month is 30 days. So 30 days times $5 a day is $150 a month. And the reason I write it that way is banks or mutual funds don't usually like you to invest every day. It's a lot of trading costs there. So they do accept every month. So a lot of times you can get your bank account drafted, take out $150 every month and just put it in the stock market or whatever investment you have. So let's try this one. So again, I always start with interest rate. In this case, we're going to say 9, just to be a little bit more conservative than 10%. Actually, you know what? The problem says 10, so in this case, I'm going to make it 10. So we'll get to some we can adjust later. Present value, we are starting with 0 in the bank. There's nothing in the bank to start with. In this case, this is recurring every day, $5, or every month, $150. So I'm paying out $150 a month, so minus $150. Again, we talked about that cash flow convention. I'm investing the money, so temporarily it's not mine. Future value, we want to become a millionaire. So 1 with 1, 2, 3, 4, 5, 6 zeros. We're going to say it's compounded yearly. And so N is going to be what we're solving for, right? So we're going to press enter. In 68 years, we will be a millionaire saving $5 a day. So if you're 16 right now, wow, 68 plus 16. is 84. When you're 84 years old, you're a millionaire. But that's the cool thing is, I mean, you only invested $5 a day. That's really not that much. You are not going to Starbucks very often, but you saved a ton of money just by putting in $5 a day, $150 a month. Not that much money. Even if you have a babysit job, you could put $5 a month. Why not start saving now? The key, though, to this is you have a lot of time to grow. You needed 68 years for that $5 a day to add up to $1 million. So the key here is having a long time. If anyone ever tells you to get rich quick, don't listen. Get rich slow. That's the way to get rich. You want to get rich slow. Okay, let's look at a housing example here. So this is kind of a reverse. I kind of like this example to work a problem here, just so you see what it's like. So in Memphis, I think this home price has gone up. This is maybe last year because home prices have been going crazy lately. But let's just say I think last year was 142,000. If the interest rate on a 30-year loan is 4%, what would the monthly payment be for a mortgage? So let's start with N, our percentage rate. Always start there at 4%. We'll come back to N in a minute. Present value is our starting point. In this case, the way a loan works is the bank gives you the money. You use it to buy the house, but it's your money and you pay the bank back every month. That's how a mortgage works. It's understood. Every month you make your mortgage payment. So I'm going to say this is positive money that I gave them, 142, or they gave me. Like I didn't do anything. I just applied for the loan, got the mortgage. Okay, payment. I'm going to delete right now. We'll come back to that in a minute. I don't know what my payment is going to be. That's what we're going to solve for. Here's the weird thing. The goal is not $1 million. The goal is 0 here, right? So if I want to pay down my mortgage, that's the goal of every loan, every mortgage, every kind of car note that you have. It's going to be 0 is your goal. You want to pay it off. These are always compounded monthly. And then the number of years would be this was a 30-year loan, so 30 times how often it's compounded, in this case 12. So 30 times 12, when you hit tab, don't press enter, is 360. So that's 360 payments you're going to make to the bank. What is the payment going to be? Tab down there, press enter, and you get a payment of $677. So you're going to pay $677 a month. So that's 677. It's paying, so that's why at point, whatever that says, 93-ish. Figure the total of all the payments over the life of the loan. Okay, so if you go to a calculator page, so I'm making 360 payments times 677.93. I paid the bank $244,000. Why would I do that? Why would I pay them so much? Do I just like the bank? You know, why did I pay them over? The house only cost 142, and I'm paying them 244,000. It's quite a bit, because you had to pay them interest. That was the difference. So if you subtract, answer minus 142, you get $102,000 in interest. So $102,000. This is money, interest. Figure the monthly payment so let's go back to the, again, menu, finance solver. We're going to make this a 15-year loan. So the interest rate now, you get a better rate on 15, so we're going to pay 2.875. Still the same loan. We don't know the payment yet. We're going to solve for that. Future value 0. N changes. It's going to be 15 years times 12 payments a year. So, whoops, which is 180. Don't press enter, hit tab. I need to press enter on the one I'm solving for, which is payment. And so I have to make a bigger payment. Now my payment's $972.11, but I didn't have to make twice as big a payment. This was our original payment. This is our new payment. This is a 30-year. This is a 15-year. So just by upping my payment a little bit, by the way, I had a 15-year loan when I had a mortgage. I've paid it off. But that is the case there. Find the total interest paid over the 15 years. I think this should be a lower number. So let's see. So 972.11. And I think there were 180 payments in a 15-year loan. 174,000. That's not as bad. 174,980. That to me was, I could stomach that figure. I'm like, I hate having to pay money, but I hate to pay money to anyone really, but that's helpful there. Um, let's do one more kind of a fun example here. So menu, finance solver. So let's say that $5 a day for fun. Let's say that you keep doing that. So let's make this interest rate 10% again. We started with $0 in the bank. We're paying 150. Getting back to that example we were doing. Future value, we don't know. Let's say that but let's say it's compounded monthly. So let's say right now you're, just for fun, I know you all are living longer than I'm probably going to live. I probably eat better too. That might be part of the reason. But also just people tend to live longer. So let's say you live to the ripe old age of 100, and until you're 100, all you do is pay $5 a day into this mutual fund. You keep, putting away money. So if you're 16 now, that would be 84 years. So 84 times the number. So how often is compounded? In this case, 12. So if you do that, you're going to make the bank. You're going to make 1,008 monthly payments of $150. Okay, so you do that for over 1,000 months. It's a long time. You're 100 years old. I wonder what you have in the bank. Remember when you were like in your 80s, you had $1 million. So how much will you have now? Wow. Okay, so let's see, 948. You have $77 million. Oh my goodness, $77 million, $290,948. So do you see the value of compound interest? This is not growing in a linear fashion. It's not like you need another 84 years to make your next million. The graph of this thing, if it makes sense, is it's going up like crazy. So you might make your first million here, but then your second million, it's doubling and doubling and doubling and doubling and doubling. So pretty soon you've got 772 million. You have $77 million when you're 100 years old. But all you put in is $5 a day. It's pretty amazing. Last thing before you do your homework is this example of rule of 72. So this is not really a calculator thing here. So the rule of 72, we'll get to the idea here in a second. So it's a way to do this in your head. So the rule of 72 says this. So you take the formula for rule of 72 is, let's see, 72 divided by the percentage rate that you're getting is going to equal the number of years that it takes to double your money. So for example, let's say I was getting 12% interest. Wow, that'd be amazing. So 12% interest, 72 divided by 12 is 6, right? So 72 divided by 12 is 6. That means it takes 6 years for my money to double. So every year, if you're making 12%, which would be amazing, every 6 years your money doubles. Put $1,000 in the bank, 6 years later, you get $1,000, right? So that's how the rule of 72 works. Now let's actually work this problem using the rule of 72. Put 1,000 in the bank, earning 3%. 3% is not as great as 12, but we'll see what happens here. So let's figure out how many years it takes to double. So 72 divided by 3. And sometimes you might have to approximate it. It doesn't work out right. I think this is 24 years. So it takes 24 years to double. It'll take 24 years. So 24 years, that's right. And so then you would be able to, like, how much until you have, that would have $2,000. How much until you have 4,000? It'd be another 24 years. So it'd be 48 years and you'd have $4,000 because it doubles. It doesn't just, give you an extra 1,000. It doubles and doubles and doubles. So that's the power of compound interest, really, is being able to see the doubling power. Your money's really growing fast. Go ahead and try your homework and see how you do. If you might want to check in the next class. I'm probably not going to publish the answers, but I will go over each answers at the start of the next class. I always do Google Meet, so go ahead and find the answers to these problems tomorrow. Whenever class is, you can log in and hear the answers.